Saturday morning here, and an absolutely miserable one at that. Had some coffee, and I've started in on the wife's car. Bit of a leak from the water pump, I think, but frankly, my head's just not in it today. It's just one of those days where you can't really concentrate, and all you keep thinking about are capstan winches. We'll leave her car up on those 4 cinder blocks for now, and we'll do ourselves a bit of machining. Doesn't that sound like a lot of... I've got a drawing here. I'll be making a capstan drum, just the drum, that will eventually be used for winching, but more on this in just a minute. First, what the heck is a capstan winch? And why will you want one once this video is over? As a visual aid, I've 3D printed a capstan drum. This would be attached to a motor of some kind, turning it into a capstan winch. For those of you that grew up landlocked like I did, a capstan is that chess pawn shaped looking pole sticking out of like ocean-y things. Boats, docks, that sort of stuff. In fact, here's one that is people-powered. It's for pulling up ropes. Anchors, nets, jump ropes you dropped off the pier, I guess that sort of stuff. Despite my signature captain's hat and smoking pipe, I'm not a sailor. So I apologize if I got that grotesquely wrong. But for our purposes, mechanically speaking, a capstan winch is a vertical axis winch, though it doesn't need to be vertical. And a regular winch is horizontal, the kind you usually see on bumpers and tow trucks and that sort of thing. Those usually do need to be horizontal, almost by definition, unless you have other stuff built into it to handle like the verticality. Cards on the table. I had to Google almost all of that. Like I said, grew up landlocked. I can count how many times I've seen a boat, let alone been on a boat. Though, not to brag, I have met a lot of sailors. I am familiar with a capstan drive or capstan mechanisms like rope drives or, I don't know, old brakes. Heck, you ever take apart an old radio with the string tuner mechanism? I don't know. Moral of the story, I've never capstan winched a day in my life. Is that going to stop me? Well, not if stopping means working on the wife's car, it's not. I'm going to assume if you're watching this channel, we're all familiar with regular garden variety winches, right? They'll give me that much. We all have a winch in the garden. Cool. Well, a classic winch is a powered drum that takes up cable. Pulling stuff, dragging stuff, getting yourself out of the mud. A motor turns a drum that the cable's attached to, and it just pulls it in and rolls it up. And a good winch has a lot of parts other than the drum. Clutch, brake, some kind of a ratchet. Mechanisms that keep the lay right as you pull the line in. It can get complicated. A capstan winch, on the other hand, does not accumulate rope. The drum is still powered, electric motor, wind power, steam turbine, a screwdriver, but it pulls rope in one side and feeds it out. Dang it. But it pulls rope in one side and feeds it out the other. It's an infinite winch. The drum doesn't get full, you don't run out of cable. It will just infinitely pull, as infinite as your rope anyway. Maybe the best way to understand this is to show one in action. Now, I can't show you because I don't own one, but I know someone who does. YouTube. This is Ohio Hilltops Hobby Farm. It's a YouTube channel. I did send a message, haven't heard back, so fingers crossed they don't mind me sharing this. But I was captivated by this video, watched it probably a dozen times. Here's a capstan drum being spun right round by a hydraulic motor. If we ignore the tractor for a minute, that's all there is to it, a drum and a motor. This particular video is about pulling sticks out of the woods. But check this out. Ohio Hilltops is controlling the winch by controlling the tension on the rope. If he stops pulling, the winch stops pulling. If he pulls, the winch pulls. He's got full control over the winching by the way he's taken in the rope. These capstan winches work purely on friction. The rope is not tied off to the drum like a classic mechanical horizontal winch. It is only the friction. And more turns is more friction. Is that wild or what? I know. Absolutely breaks my heart too, but square is all I've got. That's just what we do here. Turn square into round, round into square, and keep doing that until it's all gone. Ashes to ashes, chips to chips. It's the circle of life. I mean, I could buy the right size stock for the project, but at today's prices, come on. I'm running this at about 150 thou depth of cut. I'm just looking over at the nameplate here. 205 RPM and about a thou and a half feed rate. By the sounds of it, I think I can do a little bit more than that. That is 200 thou depth of cut. In theory, I should be able to take pretty close to 3/8 of an inch. I'm going to give it just a little bit more because I don't want to be here all day. But these big interrupted cuts just, I don't know, they scare me sometimes. This is the second pass. You can see that 1/4 inch depth of cut, maybe a little bit better there. I'm going to do another pass like this and then start creeping up on that 3/8 depth of cut, see if my machine can handle it. Pencil and paper says it can, but we'll see what real life has to say. I do not like how that sounds. The lathe isn't slowing down, but I hear some rattling I'm not used to hearing coming out of that gearbox. The chips look pretty fun, but I think I'm going to tune this back down to 1/4 inch. I'm a little out of touch, but that seems respectable. Now we're out of interrupted cut territory, and we're about to head into long, stringy chip territory. Since I get paid by the hour and not by the project. Now that we've roughed out the round stock, let me just take a minute to stop and thank my Patreons. Quick PSA, we have a lively community there, and people have a lot of hard questions. What is the meaning of our existence? Why can't my machine go more than 3 days into the future? Usual stuff like that. And because those conversations get very detail-oriented, sometimes it takes me a little bit longer to answer. But fear not, no question has ever gone unanswered, unless otherwise prohibited by the Galactic Authority. You patrons deserve a lot of love, and I just wanted to thank you for your patience. Now that we've gotten to the point where most normal people would have started, I'm going to lay out and rough in sort of the groove, the cavity that turns this cylinder into like a spool. Fun fact, I'm also out of small brushes, so we'll see how one of these things does. Probably more layout blue than I needed. Last thing I need is a call from ClickSpring. I don't even know if you can even see those. Middle lines is going to be the most roughing down to the minimum diameter. Then I've got 2 smaller lines that'll leave me some material to cut some fillets. Leave material so that smaller diameter can fillet out to the flanges. I really don't like using a parting tool that way. I've got it roughed in. That actually didn't take very long at all. I don't know how well you can see this, but the diameter, the inside diameter, the small diameter of the drum is tapered. It's a 2-degree taper per side. It's 4-degree total, but sort of flaring out this way. We'll talk about that a little bit later. I don't know if that's really critical to the function of this winch, but in real life it makes it look fancier so I could charge more. I would have liked to have made that more, maybe 5 degrees per side, but I can't handle that taper on this diameter of a drum. It starts to get thinner than I'd like here, where we'll eventually poke a hole for the drive shaft. That form tool actually did a pretty good job. I didn't have to do very much blending at all. I got a little bit of chatter on this inside face. Sometimes this kind of blending, requires like a round file. But this cleaned up pretty quick, and then as you saw, I just hit it with some Scotch-Brite. Next step is to bore the hole from the end, and I want to do this all in one setup. Like the two important features, even that's debatable, or maybe the concentricity of that bore and this face that takes up the rope. I don't think this spins very fast. Probably wouldn't be a big deal if it wobbled a little bit, but I've got a reputation to maintain. Once I bore the end for the drive shaft, I'm going to cut this off. I will be pocketing the top, but before we do any of that, I think this thing would work just as is. Like we could try it right here. I mean, we could have just done it with some round stock, but I'm curious to try this out. Hold on just 1 minute. My bench has got to weigh 400 or 500 pounds, and it's a straight shot right across from my lathe. And I have about 4 or 5 feet over there. I think we can drag it through. And on this end, I think 2 wraps should do it. Let's do 3. All right, if I just keep this from getting caught up in the chuck, here goes nothing. Freeze, turkey. What? Don't move, dirtbag. What are you talking about? Look, I don't know how you say it in 2025, but do not use this lathe as a winch. Why not? It'd totally work. It will work, but your bench weighs more than you think it does. You end up pulling your lathe over, hurting yourself, and more importantly, bending the spindle. And I cease to exist. Are you me from the future? Obviously. Dang. We still need to keep that fingernail covered, huh? Well, that's a bummer. We'll just keep trucking, as they say. Figure something else out later. I know a lot of you were wondering what the other side looked like. There it is. I've got it flipped around and in the 3-jaw chuck. Again, the 2 important features, the diameter of the take-up and the bore where this part gets mounted, are concentric. They were all done in one operation. Anything else I do now can't affect that, unless I come in and I recut this surface, which I'm not. And there it is. I skipped ahead a little bit while you weren't looking. I apologize. Sue me if you must. But I'm running out of time with this thing, and really, there wasn't that much more to see. Except this keyway. Ignore that hole for just right now. I split this part into 2 pieces. This cap will get screwed down into the big cavity I bored. Down in there. Let's see if I can walk you through this as painlessly as possible. As drawn, this thing had a blind keyway. That means it was a big solid cylinder and just a bore in one end with a key slot. I can't do that. It would go against my moral code. I'm just kidding. There's a couple of ways I've done that in the past, but none work for this particular situation. Long story short, this gets mounted on a stub shaft. In this case, a keyed shaft that comes out of a gearbox, I think. That shaft has a screw on the end that would retain the entire capstan drum. If I hadn't bored this side out, the keyway, that keyway, would just have to stop like 2 inches down into the part, into a solid part. Now, the only way that I know to do that is with a sinker EDM. You burn it in. Don't tell my friends down at the country club, but I don't own a sinker EDM. So, I used a keyway broach. Still a chip in that. We've seen these before on this channel. It's just a really thick saw, and it's pushed through the hole. Why can't I line that up? It's pushed through the hole in like a press of some kind, and this thing cuts a keyway the same size as the broach. It's held in place and in position with one of these bushings. Drop the bushing in, clock it to where you need it, and just start pushing that broach through. Oh, so now it lines up, huh? The problem now with the top cutout is there's no way to actually locate this capstan. There's no roof in there to bottom out the stub shaft. So I made this big thick washer. just drops down from the top and gets 3 screws. I've only done one so far, only one hole so far. It gets 2 more because, well, it's slow and tedious. I'm doing this with some comedically long drills and taps, like this kind of nonsense. And the drill especially just wants to wander outside the lines. If you really need to cut a blind keyway without jumping through these hoops and don't want to send it out for EDM, you have to cut clearance down at the bottom of the keyway somehow. If you have that clearance, you can sort of slot the keyway in a lathe or a mill using tools like a shaper, but you need clearance at the end where the keyway stops. Otherwise, you're just trying to compress solid metal, which can sometimes be difficult. I have cut that clearance before with like a grooving tool in the lathe, reach down in there and cut a round groove. Sometimes that's okay, but it would take a lot of material out in an important section of this drum. It might weaken the part. Alternatively, you could go down there and like sort of locally cut some clearance with a T-slot cutter just where you need it, but I don't have a T-slot cutter that works in this case. Or, lastly, the quick and dirty way, if your boss ain't watching, just drill a hole in the side of the part that intersects with the end of the keyway. Anything you can do to get in there and create some space for that key cutter to sort of finish in and break chips. Now, because this particular part gets rope wrapped around it tight, I didn't really think a big sharp hole in one side would be that smart. I didn't want to make a rope shredder. So I went with a cap. I turned it into 2 pieces. That key will take up the torque load, which is a lot, I imagine, and the cap will take up any axial thrust, which shouldn't be that much. At least nothing that 3/4 inch screws couldn't handle. Check this out, a baby capstan. Unfortunately, I won't be able to show you the big one in action, but I figured we could play around with something more my speed. And I mean, this is it. This is really all there is to a capstan winch. This and some way to turn it, of course. Now the lathe apparently is not a smart idea. A cordless drill would work, but wouldn't make for much of a winch since I'd just be pulling the drill. I'd have to like mount the drill to my bench. I don't know, I don't like the drill idea. I did think about mounting this on the rear axle of my wife's front wheel drive car, since it's just sitting there asking for it. But then I realized all we have to do is spin this. So, who here remembers right round? This is my weld positioner. And you know what it does? Well, it just spins. I know, right? This thing is awesome. I use it for absolutely everything except welding. The back has a bit of stub shaft sticking out. This is where I attach my ground clamp, and this just fits on here. All right. What do you think of that, huh? All you welders out there having trouble pulling in work for your rotary table? Well, you're welcome. These two are essentially the same thing, other than the size. Now, technically, this thing probably doesn't even need a groove in here. I imagine that's just to keep the rope from falling off. I'm speculating here. This has a taper, like I mentioned. This does not. And I think the taper is just to keep the rope on one side. Here, I imagine it might just walk all over the place. On a tapered one, I imagine that rope would just come over to one side. But enough yapping. Let's try this thing out. Ugh. Holy poop, is that heavy. I have no idea what this thing weighs. I'd go so far as to say it is unknowable. I've got some low stretch rope here. Should be good to 50, 60,000 pounds. We'll measure this in a minute, but for now, I just kind of want to try it out. I'm curious. Now, my bench isn't the smoothest in the world. I hit it with an angle grinder, just tried to clean it up a little bit. We may hit some snags, weld spatter, that sort of stuff. But let's see how this feels without a winch. All right, sliding, not that bad. As you might expect, it was sort of harder to get it started. I don't know, it felt like maybe 10 pounds. Now, let's try it with a couple of wraps on the old capstan here. Might be too dark for you to see it, but I've got some bench dogs. One on both sides of the weld positioner, just so it doesn't move or turn itself around on the bench. Okay, no tension, everything is slipping, nothing is moving. Just gonna pull. Would you have a look at that? That feels like maybe a pound? Not even. That is too cool. I've got this scale, not the best scale in the world, but everything else I have starts at like 500, 600 pounds. Let's just see, am I in the frame there? Hello? always something. I got this awesome scale, best scale in the world. Yes. This, like the other one, I think is like a 50-pounder. So we're gonna fall off the scale pretty fast, but still, hopefully it gives us sort of an idea of what the winch is doing. I don't know if you can read that, but I'll tell you what the number is. We're up to 5, 6, rope is stretching a little bit, 7, 8, just moved a smidge, 10 pounds, 11 pounds, 12 and a half pounds, 13.5. That's probably the irregularity in my bench. Let's try that one more time. It's jumping around, but it looks like it peaked at 12 and a half, 13 pounds. I'll write that down, 0 turns, 13 pounds. Now we'll try it with just 1 turn around the capstan. Like I said, this scale, I assume, is not going to be very linear. And based on how this felt, next to weightless, I don't think we'll get very accurate measurements, but hopefully we see a trend. So here we go with 1 turn. The weight's just starting to move, and I'm at 4 pounds, 5.5 pounds. Okay, I don't know how to lock the number on this dumb thing. A lock pops up by itself just at the most random time. But it peaked at 5.5. Once it got going, it was down around 4.5. It starts to slowly climb again, but I think that's because I'm not pulling, like the closer that gets, the more crooked. I'm starting to try to lift that weight up. 4.5, 5.5, let's call that 5 pounds. 1 turn, 5 pounds. 1, 2 turns. Notice nothing is happening. The weight's not moving because I have no tension on this rope. Everything's just sort of slipping, no friction. You guys tell me, whoa, holy smokes. I hardly touch it. It started dragging the weight. Zero it out again. I'm keeping one eye on that steel cylinder and another eye on the scale. 1.6? 1.6. So 2 turns, 1.6. 1, 2, we'll do 3 turns now. Trying to avoid making a knot here because I have to keep moving up the rope. 3 turns, 0 on the scale. Oh, that's impossible to... 0.7, 0.8, 3 turns, 0.7. That was a 1.6. 1, 2, 3, 4. I'm not even really registering a number. As soon as I give the slightest bit of tension to this rope, I'm moving that weight. 0.3 maybe if I had to take a guess. I bet just the weight of the scale will pull that. I hate to even write this down, but I don't know, 0.3. Anything less than 5 is kind of baloney. I don't think the scale can resolve that, but you can see it's given us a trend. It's magnifying pulling force, right? With no turns, it takes me straight up 13 pounds. With 4 turns, I only need 3/10 of a pound to move that same weight. In fact, let's just see what sort of that amplification factor is. 13 over 13, that's 1. So that's 1 to 1, obviously. Let me get my calculator so I don't do anything stupid. 13 divided by 5 is 2.6. 13 divided by 1.6 is 8, 8 1/8. Let's call it 8. That's 18 and a half. 0.3, that's 43. So just 4 freaking wraps already gets us to a 43 to 1. Anyone happen to notice the trend with those numbers? Those numbers? Like my wife said on our honeymoon, that's exponential. Sorry, not meant to be vulgar innuendo. Literally, her eyes started to glow, she started levitating, and she predicted the future. Put a little bit of a damper on the mood. Would you be surprised to learn that there exists a capstan equation? Like a real life math equation? I was. Couldn't tell you why, but when I saw it, it made me laugh. For some reason, it just strikes me as oddly specific. I do realize that's the whole point of science, but still. I mean, check this thing out. And don't freak out, it's not as bad as it may look. In fact, much like myself, the more you stare at it, the handsomer it gets. There's really only 3 things in there, 3 numbers. It's telling us the load force is equal to the hold force times some number. Okay, I'm being a little lax in my terminology there, but that's all there is to it. It's just multiplying 2 numbers. Thing is though, that second number is exponentiation, and it can get freaking huge in a hurry. In case you're wondering, that E is just a number. Granted, a very special number, but it's like kissing cousins with pi. Just like pi is 3.14 whatever, E instead is 2.7 something something out to forever. The real kickers here though are those exponents. That posh looking snobby U is coefficient of friction. In this case, the friction between the rope and the drum. Rough rope on a knurled drum, that'd be a bigger number, bigger coefficient. Smooth rope on a polished, greased drum would be a smaller number. And theta, that zero looking number wearing a seatbelt because it knows what's about to go down, or up maybe, that's basically the number of turns of rope wrapped around the winch. So it's friction times the number of turns, E raised to that power. The force numbers are easy to know or to find. You could measure them, even though the whole point of this equation is to try to figure them out. The number of turns, well, you can just count those. The only thing hard to figure out maybe is the real coefficient of friction between your rope and your winch. So I did what anyone would do, ask the internet. What is my friction? I didn't find it. Honestly, I didn't look that hard and my question was maybe a little vague. But in my 2 minutes of Googling, look what popped up from Wikipedia. A freaking chart with the exponential term already worked out for us. Again, oddly specific, but I'll take it. This chart is showing us the quote-unquote gear ratio with different combinations of friction and number of turns of rope. It's just doing math for us. And would you have a look at that? 3.5 billion with 5 turns of rope. If my best friend told me that number while we were sitting in a bar, which would totally be in character by the way, but if he said a number like 3.5 billion, I'd bet good money he was probably stretching the truth a little bit. But anyway, check out the coefficient of friction numbers across the top. In a way, it doesn't even matter what that number is. Like say you don't know what your friction is. These numbers are growing so fast, I mean, who cares? You just throw one more turn of rope on. Crazy numbers. The article goes on to say that, more or less, the factor of 153 million, it says, in theory, that a newborn baby would be capable of holding, not moving, the weight of 2 USS Nimitz supercarriers, which were like 100,000 tons each. But for the baby, it'd only be a couple of pounds. Now, the not moving part is worth talking about. Maybe just to state the obvious, you wouldn't want to confuse the holding factor or the gear ratio with winching power. Just because 2 more turns of rope on here gives me 200 Brazilian pounds of load force from 1 pound of holding doesn't mean I could winch that. We're still limited to the power rating of our motor and the structural strength of all the parts. Just wanted to put that out there. It doesn't say so explicitly in the Wikipedia article, but I'm pretty sure 2 USS Nimitz supercarriers would tear a baby in half. Not 100% sure, never tried, probably wouldn't be pretty. That exponential behavior, by the way, also explains why capstan drums tend to be so compact. I mean, in comparison, I kind of went to town with this one. It could have been half this size, half this length. According to that chart, you really only need 3, maybe 4 turns of rope tops. I mean, even if you went crazy and did 5, this is still twice as big as it needs to be for the rope. Anyway, I think that's all I got. Yes, I do realize I'm late to the capstan party, but these things are just freaking amazing. That, or I'm easily amused. Tomato, tomato. Now, of course, you can buy these things. You don't have to make your own. Just Google it. You'll see them. They even make them as accessories for chainsaws. Or 12-volt versions you can put into a receiver hitch. All sorts of crazy and fun variants of these capstan winches. Oh, and thanks again to Ohio Hilltops for letting me use their video. I'll be emailing you again, by the way. I may need to borrow your tractor. For everyone else, I'll leave a video link down in the description. Be sure to go and check it out. It's a pretty fun video. Here's hoping everyone has, or had maybe, not sure when this video will be ready, a great Thanksgiving. And as always, thanks for watching.